Chapter 6, Lesson 3. Welcome. Welcome, welcome. So today we're going to determine whether a quadrilateral is a parallelogram. So using the characteristics that I know to make sure that a quadrilateral, four-sided figure, is a parallelogram. So these are the 5 things that could determine if a quadrilateral is a parallelogram. If you look through these 5 things, all of the then statements are the same. Then, the quadrilateral is a parallelogram. So just like 6.2, I'm going to draw the picture that would look best for the theorem. So if both pairs of opposite sides of a quadrilateral are congruent. So if I'm doing 6.8, and if here was my shape, if I know that my opposite sides are congruent, then this will be a parallelogram. 6.9, if here's my shape, and if I know a quadrilateral is supplementary to both its consecutive angles. So if I label these angles, if I know angle C plus angle D, and also angle C plus angle B are equal to 180, then this is going to be a parallelogram. So again, you have to know 2 sets. Can't just be 1 set of angles. 610. If this is my shape, if I know both pairs of opposite angles are congruent, then it's going to be a parallelogram. So if this is congruent to this, and this is congruent to this. So a lot of these are going to be the converse of the theorems that we've already talked about. So 611. If I know the diagonals of a quadrilateral bisect each other, so if these are my diagonals, if I know this small length is equal to this small length, and this small length is equal to this small length, then it is a parallelogram. And finally, 612. If this is my shape, if I know one pair of opposite sides of a quadrilateral is both congruent and parallel, then this will be a parallelogram. So if in this shape I know these are congruent, and I also know these same lengths are parallel, this is going to be a parallelogram. So those are the 5 theorems that I have to state if a quadrilateral four-sided figure is a parallelogram. So in this picture it says what value of x makes this a parallelogram. When I look at the picture, I have sides. How do I know that they're sides? It's because the equation's on the outside of the figure. If it were on the inside, then I would have angles. So in order to prove this is a parallelogram, my opposite sides have to be congruent. That's one of my theorems I just talked about. So I'm going to set up 2 different equations. X plus 8 has to be equal to 5y. And also 4y minus 3 has to be equal to 2y plus 5. But I'm actually just looking for x. So how am I going to solve this? This equation has just y, so I'm first going to solve for y. So I'm going to subtract 2y from both sides of my equation. So I have 2y minus 3 is equal to 5. Add 3 to both sides of my equation, and I get 8. So y is going to be equal to 4. I'm going to use this to help me solve for what x is equal to. So I'll have x plus 8 is equal to 5 times 4. So x plus 8 is going to be equal to 20, and then subtract 8 from both sides, and x is going to be equal to 12. This is the only value that x could be equal to in order to make this a parallelogram, so my opposite sides are congruent. So here I have 2 different problems. I'm not going to write down a formal proof. I'm just going to talk through it. So if you are not listening, this is going to be very difficult for you. When I look at this, I have that AE is congruent to CE. I also know that DB is 2 times DE. So I'm dealing with my diagonals. And in order to prove that a quadrilateral is a parallelogram with diagonals, I have to make sure that they bisect each other. I already have that with one diagonal because AE and EC are congruent. So now I have to use this information to help me state that BE is equal to ED. That's what will help me solve that this is a parallelogram. So if I look at B or DB, this whole length, instead of writing BD, I'm going to write BE plus DE. That's equal to DB. So now instead of writing DB, I'm going to put this in place into my equation. So now I will have BE plus DE is equal to 2ED. So now when I'm looking at this, I'm going to subtract DE from both sides of this equation. Remember, DE is the same thing as ED. Now I have BE is equal to DE because there was 2 here. Subtracting 1 is just going to give me 1 left over. So I'm going to draw that on my picture. BE is congruent to DE. Now I basically solved that this is a parallelogram. Why? Because my diagonals bisect. So if I look at my second one, I'm going to label information given. So 49, C is 131, and W is 49. In order to make this a parallelogram, 2 sets of consecutive angles have to be supplementary. So first I'm going to check these 2, and then I'm going to check these 2. So 49 plus 131 is going to be equal to, you got it, 180. So since that is equal to 180, my red 49 plus 131 will be equal to 180. Now, why is this a parallelogram? Because 2 sets of consecutive angles are supplementary. So just showing your work is not good enough. You also have to tell me why this is a parallelogram. So word problem. This table tray can be adjusted up or down by raising or lowering the table on its hinged legs as shown. Will the table always remain parallel to the surface that it sits on? Explain. When I look at this, I have these 2 are congruent. I also have these 2 are congruent. So yes, the reason being is because this is a parallelogram. Why is it a parallelogram? Because opposite sides are congruent. So that's why a parallelogram is always parallel. So yes, you need to have all this information. You can't just say yes. You have to say why. Is it a parallelogram? And being a parallelogram, it will always be parallel. Make sure you fill out the Google Doc and submit your answers. Have a great day.